Now we will discuss the reflection of light and its laws. When light falls on the surface of a material, it is re-emitted in the same media without change in the frequency. This phenomena is called the reflection. So reflection is when light falls on surface of a material, it re-emitted in same medium without change in frequency is called reflection, and wave is called reflected wave. Suppose this is the material boundary. On this we draw a perpendicular that is called the normal, represented by n. A ray incident on the surface, this is called incident ray, represented by I. It makes an angle I with the normal, this is called the angle of incidence, and after striking it get re-emitted in the same media without change in the frequency and results into the reflected wave. This wave is represented by R, and angle of the reflected ray with the normal is small r, that is called the angle of reflection. So I is incident ray, R is reflected ray, N is normal, I is angle of incidence, and R is angle of reflection. Here we have used a term ray. Ray is imaginary line which is perpendicular to wavefront and gives direction of propagation of the wave. Wavefront is the surface at which all points are in same phase. This term will be later discussed in wave optics. Similarly, if we take a curved surface like a convex surface, if at a point the tangent is drawn and normal is perpendicular to this tangent, so normal is shown here. A ray incident at the surface at point where normal meets at the surface, this is the incident ray, and after striking it re-emitted into the same media, this is the reflected ray. Angle of incidence is the angle between the incident ray and normal, and angle of reflection R is the angle between the reflected ray and the normal. There are the two laws. First, incident ray, reflected ray and normal are coplanar. That means all these three lie in the same plane. And angle of incidence is equal to the angle of reflection. So these are the two laws that are known as the law of reflections. Now we take a special case of the normal incidence. Suppose this is the plane surface and n is the normal, and now a ray strikes at the surface along the normal. This is the incident ray, and because I and n are parallel, therefore angle of incidence is 0. And by the law of reflection, angle of incidence equal to angle of reflection, so it is also 0. Therefore the wave after reflection re-emit into along the normal as shown in the figure. So for normal incidence, we have to remember that angle of incidence and angle of reflections are 0. Similarly, if we take the curved surface and at a point tangent and normals are drawn, and if a ray strikes along the normal onto the surface, this is the incident ray. Here also angle of incidence is 0, and because angle of incidence equal to angle of reflection as per the law of reflection, so this angle of reflection is also 0, and ray get re-emitted along the normal and makes angle 0 degree with the normal. So angle of incidence and angle of reflections are 0 for the normal incidence. Next is angle of deviation. Angle of deviation is the angle between incident ray and reflected ray. If reflection is under consideration, then we will use the reflected ray. If refraction is under consideration, which we will discuss later, then this angle is between the incident ray and the refracted ray. So taking the reflection under consideration, this is the plane surface and n is the normal. A ray strikes at an angle of incidence I, then after reflection, it re-emitted in same media with the angle of reflection R, where angle I equal to angle R. If we see the angle between incident ray and reflected ray, this is the reflected ray and this is the incident ray, then we further draw I, and the angle between I and R is shown by angle delta. This is the angle of deviation. So angle of deviation will be equal to pi minus angle I plus angle R. And because I and R are equal, say it is equal to alpha, so we can write delta equal to pi minus 2 alpha. This is the angle of deviation. Similarly, if the surface is the curved surface, then here it is the tangent and n is the normal. A ray incident, which is the incident ray at an angle of I, and it get reflected into the same media with angle of reflection R. Angle I equal to angle R as per the law of reflection, and suppose it is equal to alpha. Then if we further extend I, then delta is the angle of deviation between the incident ray and the reflected ray. So here also angle of deviation delta will be equal to pi minus angle I minus angle R, or we can write it as pi minus 2 alpha. So we can say delta or the angle of deviation is the pi minus 2 alpha, where alpha is the angle of incidence in case of the reflection. Further, if we draw the graph between delta and alpha, because delta equal to pi minus 2 alpha, so it is equation of a straight line, which is similar to the equation of a straight line as mx plus c. M will be equal to minus 2, which is the slope, and y-intercept c is equal to pi. Here, if we put alpha equal to 0, then delta equal to pi, and if we put delta equal to 0, then alpha will be equal to pi by 2. And now we draw the graph. This is delta, this is alpha, and graph will be like this. Here delta is 0, so alpha is pi by 2, and at this point B, alpha is 0, so at alpha equal to 0, delta is pi. We can see these two conditions 1 and 2. For condition 1, we have write that alpha equal to 0, then delta equal to pi. Alpha equal to 0 refers the normal incidence, and normal incidence have the angle of deviation pi. This is the surface on which n is the normal and ray incident along the normal, so alpha is 0. And this ray after reflection returns onto the along the normal, and direction of incident and the reflected rays are opposite, so we can write that Angle between the incident ray and the reflected ray are pi. So angle of deviation is pi. Second condition is if alpha equal to pi by 2, then delta equal to 0. This is the surface and n is the normal to this surface. A ray perpendicular to normal incident on the surface. Then angle of incidence is 90 degree. And after reflection, angle of reflection also 90 degree. So it will also moves along the same line. That means there is no deviation into the incident and the reflected ray. Hence, we can say angle of deviation is 0.